All right, we are live on Trigonometry Basics. Let me go ahead and maximize this. There we go. All right, hopefully it's recording. All right, state the quadrant in which the terminal side of each angle lies. Okay? So the best way to go about 1 through 8 is just to sketch or think about where that angle is going to be. A lot of people like to sketch it. Is there an echo? Is that me? It's a little echoing. Is that better? Yeah. Okay. So I want to make sure that, for example, 290 degrees, what I always tell students to do is when you're doing these problems 1 through 8 and you're looking at where they're going to lie, go ahead and draw yourself a quadrant, and just one quadrant will do, or one axis, set of coordinate axes, and go ahead and label in degrees and radians all of the axes. So this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees. And then also label the radian measures. So this would be 0 rad, this would be pi over 2 rad, this would be pi rad, this would be 3 pi over 2, and this would be 2 pi. Okay? Then you can look at this and say 290. Well, where is that going to work out to be? In which quadrant? Well, that's pretty easy to see. It's going to have to be between 270 and 360, so that'll be quadrant 4. And if you're a person that doesn't remember the quadrants, go ahead and label the quadrants too. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Make sure you know the quadrants. Okay? So then you could go through these problems. So number 1, it lies in quadrant 4. Now, problem number 2, when you have a negative angle, what's the only difference?
So the other way around.
You're going to go clockwise instead of counterclockwise. So negative 166, if 0 to 180 is this way, 0 to negative 180 would be clockwise. So you'd actually be somewhere here located in quadrant 3 for negative 166. So that'd be quadrant 3. What about 220? Where's that going to lie?
3.
Quadrant 3. Where's 355 going to lie?
4.
Quadrant 4. Where is negative 17 pi over 6 going to lie? Well, I know that I'm going clockwise. Remember how many pi over 6s it takes to go around?
2.
12. Okay? So, yeah, well, it's going to go, yeah. Well, it's not going to go quite to 2. So you're going to go negative, you're going to go clockwise, so you're going to be, if I go one rotation all the way around, that's 12 pi over 6 in the negative direction. Now I have to go up to 17, so I've got to count out 5 more. So I'm going to be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, so it's going to land me in quadrant 3. Okay? Make sense?
Could you just multiply 17 by 180? Means you know that.
You could convert it to degrees, but once you get good, I want you to get so engrossed into radians you don't have to do that. Later on, we won't even touch degrees. Okay, 5 pi over 6, that's going to be in quadrant 2. 9 pi over 4, well, you know it takes 8 pi over 4 to go around once, right? How do I know that? 8 pi over 4. How do I know that? Because that divides out the 2 pi.
To be in quadrant.
So it's going to be in quadrant 1. If 8 pi over 4 goes around once, then 9 pi over 4 puts you in quadrant 1. 19 pi over 12. Pi over 12s, if you don't know what pi over 12 is, what is pi, first of all? Pi is 180, right? In degrees. Somebody do 180 divided by 12. What is 180 divided by 12? Huh? 15. So pi over 12s is 15 degrees. So I'm counting by 15s. So I'm going to do 9 15s. Well, let's just go 9 times 15 degrees. 19 times 15 degrees. What's 19 times 15? What am I going to get?
285.
285. So what quadrant is that in? Where's 285 going to land in? Quadrant 4. So probably the easiest thing to do here for most of you is convert it to degrees and then just figure out which quadrant it's in. But that's the idea there, is being able to count. I would know that it takes 12 pi over 6 to go the whole one rotation. I'd know that it takes 8 pi over 4s to go one rotation. I know that it takes 6 pi over 3s to go one rotation. Okay? Once you get the hang of that, that's not very hard. I'm not going to spend a ton of time there. So, moving on. Find the measure of each angle. You were supposed to use some information given in the table to be able to find the measure of the angle given. And you want to find the measure of the red angle. So if this is 75 here, we know that this little blue acute angle would be what? So this right here would be 15. So that should help me find that red angle. Well, if I'm going clockwise, first of all, the answer has to be what? Negative. So I'm going to go back all the way, except for I'm going to come short 15. So all I got to do is do 360 minus 15, and that'll give me what? So it's going to be negative 345 degrees. Okay, any questions there? All right, I'm going to move on a little further here. We'll go over the rest of these answers tomorrow. I'll let you check them tomorrow. Same thing for here, pi over 6. Pi over 6 is really what, everybody? 30 degrees. So you know you're 30 degrees back from 270. But look how it's going. It's going positive. Ready? Positive rotations. So it goes around once. That's how many pi? 2 pi. Goes around twice. How many pi is that? 4. A lot of pi out there.
How is that
That's a
positive?
negative.
That's negative.
Okay, it's negative 4 pi. Negative 2 pi, negative 4 pi. Now we go back. How far are we going back if we go a quarter quadrant? Pi over 2, so it's, think of it like this. You went, here I'll do it in green. So we went back, there's negative 2 pi. I've got negative 4 pi up to that point. Now we go back how much more? Plus negative pi over 2, plus how much? Negative pi over 6, and these are all negative because we're going which direction? We're going clockwise. Now, you can cheat with your calculator, and you can add this up with your calculator without the pi's. You could go negative 4 plus negative 1/2 plus negative 1/6, hit enter, change math, change it back to a fraction, and then just put it in terms of pi. Or you can do it the long and hard way, which is by hand, and figure out what the common denominator would be. What would the common denominator be? 6. So that right there is going to be, if we're going to have a 6 for a common denominator, this is going to end up being negative 24 pi over 6 plus, that's going to end up being negative 3 pi over 6. Agreed? And then this will just be plus negative pi over 6. If you add all these up, so you're going to end up with negative 28 pi over 6, which does reduce to the negative 14 pi over 3 for the final answer. There's other ways to do this. I'm just giving you one way. I mean, this is kind of the by sheer brute force way of doing it. Yes?
Is it wrong that since pi over 6 is 30 degrees, if I put it in degrees?
They want it in radians. Okay? On this one, they want it. Huh?
So it's fine to measure each angle.
Well, if it's
If they give you radians, they want radians. If they give you radians, measure is radians or degrees.
Yes, it is wrong.
It would, but I'd have clarified a little bit clearer. I would have said make sure your answer's in radians. So you would have known. It was a little bit ambiguous here because they didn't really specify in the directions, but you're just supposed to assume since they gave it to you in pi over 6, leave it in radians. All right, drawing an angle with the given measure in standard position. Can everybody handle this down here? This is just practicing sketching those angles if they're given. So negative 280, for example, 15. I'll do 15. I'm going negative direction, so I'm going clockwise. So I'd go back 180. Pretty close, right? Okay, it's 270. 280 is going to be about right there. This is what it looks like. So this is your negative 280 degrees. Does everybody see how to draw an angle in standard position? What does it mean to be in standard position? Starts on the positive x-axis. That's where you measure from, the positive x-axis. Okay? Yeah, you do. That's how you draw an angle. Now you know. And it's okay if you didn't last night. I'm just kind of going through this. I mean, there's a lot of stuff here that we probably just forgot. Yeah, you're supposed to draw the arc. Okay? You may page down. Apparently you can't. Did not work. Radians, same thing. Let's see, for example, negative 13 pi over 6 or 13 pi over 6. How many pi over 6s does it take to go around? 12, because you're counting by 30. So if I go 13, it's like 1, 2, 3, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9, 10, 11, 12. So 13 pi over 6 is going to be right here. Here's what the angle looks like, guys. The reason you draw the arc, without the arc, you don't know you went more than one rotation. So here's the angle. You ready? There's 13 pi over 6. That's what it should look like. when you draw the angle in standard position, you do need to draw the arc. Otherwise, if you just draw, see if somebody just did this, is this angle, the one in red, different from the 13 pi over 6? Definitely. The one in blue is a much bigger angle. The one in red is a very small angle. Now, they are coterminal. Remember what it is to be coterminal? If you're co-workers with somebody you work in the same building, doesn't mean you're the same employee. If we're coterminal, it doesn't mean we're the same angle, but we do terminate in the same place. Okay? So coterminal just means they terminate in the same location. All right? Any questions there? Speed this up a little bit. I'm dragging my feet. Reference angle. This is just, what did I say a reference angle was yesterday? How far the angle is from the x-axis. It's that simple. How far is it from the x-axis? So 95. How far is 95 from the x-axis? 85. How far is 105 from the x-axis? 75. How far is 165 from the x-axis? 15. How far is negative 290 from the x-axis? 70. And we're like, really? Yeah, really. Think about it. If you go negative 290, you're going to go back 180. You're going to go past 270. You're going to go to negative 290, which is right there. So there's negative 290, which happens to be coterminal with 70. 70 away from the x-axis. Okay? Just using geometry and what you refer to in geometry as addition. Let's see, what is it? Geometry addition postulate. Yeah, you're just, taking angles, and based on the fact that the total sum is 180 or 90 or whatever, you just add and subtract. Okay? Segment addition postulate, or angle addition postulate is what it was called. Okay? What about 295? How far is that away from the x-axis? Huh? 65? You sure?
What? 25.
It's from the x-axis.
I did it from the y-axis.
No, it's always x-axis. Reference angles to x-axis. So 295 is right here, right? So how do you get that?
360 minus 95.
360 minus 95 would be what? 65.
65.
65 degrees. Okay, what about negative 95? 85? Now, you're going to laugh at how easy the radians are. The radians are easier to do. Because here's all you do with radians. I'll show you how fast I can do it. I can do 27 through 32 in less than 3 seconds.
Okay.
Down that.
Challenge accepted.
You ready?
Come.
Pi over 4, pi over 3, pi over 4, pi over 4, pi over 4, pi over 3.
That was 4 seconds.
No, it wasn't. It was less than 3.
28 wrong, isn't it?
No, I don't. You just look at it. It's whatever it's in terms of. You drop the numerator off.
Really?
Yeah, every time.
So it's pi.
When it's your common angles. Now, if it's not common angles, that doesn't work out. But whenever it's a pi over 4, a pi over 3, or a pi over 6, or a pi over 2, you drop the numerator and it's just the pi over the denominator. That's the reference angle every time.
With the negative? Or?
No, you drop the negative. Reference angles, if you were here yesterday, are all positive angles. So you always drop the negative. So you just drop, all it is, pi over 4, pi over 3, pi over 4, pi over 4, pi over 4, pi over 3. And it only works with common angles, though. If you do something with like a pi over 9 or pi over 18, it probably won't work. It works sometimes and it doesn't work. It doesn't work as consistent. I think at pi over 9s it works, pi over 18s it doesn't. I can't remember. But common angles, it always works. It just works. Because when we did our unit circle, the way our unit circle worked, our 30s, remember our patterns? Our 30s always ended up being pi over what? Come on, help me. Pi over 6s. Every time they ended up being a pi over 6s. Our 45s always ended up being what? Our pi over 4s. Our 60s always ended up being what? Pi over 3s. That's why it's always worked. Every time you see an angle, as long as it's a reduced fraction, as long as the fraction is reduced, if it's not simplified, it's not going to work. But as long as it's simplified, it's just the pi over the denominator if it's a common angle. Pi over 3, pi over 6, or pi over 4. And that's all we ever do anyways. So you don't have to worry. So that's how easy those are. Are you glad I showed you that?
Yeah.
Okay? It's gonna make, you're going to like radians better for that very reason. Convert degrees to radians. How do we convert degrees to radians?
Multiply.
Multiply by pi over what? 180. Why do we want the 180 on bottom? So the degrees cancels. So this is going to end up giving me negative something. I can do the math here. I can cancel the 0 out because that cancels out of 10. And then 4 and 18, 2 goes into both. So I can go 2 and then 9. So it looks like it's going to be negative 2 pi over 9, and you do need to reduce. But did I show you how to reduce with the calculator yesterday?
Fraction.
Yeah, you just hit your math button, 2 fractions, but you don't put the pi in there. We treat the pi like a what? A variable. So how do you convert these into degrees?
Multiply by 180.
Multiply by 180 over pi. What always happens to the pi? Cancel. So what a lot of students do is they kind of shortcut it and they say, well, since pi is 180, can I just drop the pi out and change it to 180 and go ahead and convert it to degrees that way? Absolutely. So like negative 23 pi over 6, what would that be? Negative what? 690. And that's how you do those. Okay, any questions so far?
No.
Does this help?
Yep.
Negative 113 pi over 36, what did that end up being? Huh? Is it negative 565?
Yeah.
Okay. So this one was negative 565. And again, if you know pi is 180, you just go 113 times 180 divided by 36. It is negative, so it ended up being negative 5. You said negative 565? Is that what you said? Okay. Alrighty. Coterminal angles. I didn't talk a lot about coterminal angles except for the definition. To find a coterminal angle between 0 and 360, what do? What is a coterminal angle?
It's something that has the same, like, position on the.
On the terminal side, right? Yeah. All you have to do, how far apart are angles from each other? Oh, one rotation. An angle is always one rotation away from the same angle, or an angle that will terminate in the same location. It's not the same angle, okay? 30 and 390 are not the same, but they do terminate in the same location. So anytime you want to find a coterminal angle and it's in degrees, you just add or subtract what? 360. If you want to do it in radians, you add or subtract. All right, everybody say that with me. If I want to find a coterminal angle in degrees, I add or subtract what? If I want to find a coterminal angle in terms of radians, I add or subtract what? 2 pi. 2 pi is not as fun to add. So find a coterminal angle between 0 and 360. If I'm at 610, do I need to add or subtract to get between 0 and 360? Subtract. So what are you going to get?
250.
250 for that one. So I just subtract 360, and that'll give me my answer. What about this one? Add or subtract?
Subtract.
Subtract. What do you get?
193.
193. These are pretty easy. 53 pi over 18. I don't know. Is it bigger or smaller?
17 pi.
Yeah, I would probably subtract. Looks like it's pretty big. If you're not sure, convert it to degrees real quick, especially these weird ones that you don't know, and then convert it back to radians, I guess. But I'm just going to subtract 2 pi. How do you subtract 2 pi from that fraction? Common denominator. So it'd be 53 pi over 18 minus, if I put a common denominator, it's going to be 18. What's the common denominator? How am I going to make that an 18?
It'll be
Yeah, it'd be 36 pi over 18. So it'd be 17 pi over 18. And we need to check, is that between 0 and 360? Is that between 0 and 2 pi?
Yes.
How can you be sure?
because it's almost 1. Because it is. 'Cause it's not even 1 pi.
Yeah, you know 2 pi is all the way around. This is not even 1 pi. 18 pi over 18 would be 1 pi, so you know you're not even close to 1. You're almost to 1 pi. Okay, really? Okay, negative, now that's got to be on my video. Okay, who was
So you
that?
say that it was Dan.
Yeah, it was Dan.
Finger Brad. His last name is.
Okay. Find a positive and, I'm going to make it private so it ain't going to matter. Find a negative and positive coterminal angle for each given angle. Do you know how to do this?
Yeah. You just add
It's rocket surgery. What do?
You add 360 if it's positive 100, and then you just keep.
What about if it's really large though? What about if it's like 1200? You're going to have to keep subtracting 360 until you get to a negative coterminal angle. You can add or subtract 360 as many times as you want. So if I want one positive, one negative, well, one positive one, I could just add 360 and I'll get another positive one. Negative one, so I'm going to have to keep subtracting 360 until I get to a negative answer. Somebody give me one, let's just do this first one, 698. Give me one possible positive.
58.
158. He subtracted 360 and still had a positive one.
Negative 22.
Is that right?
Yeah.
That doesn't seem right.
1058.
So
Okay, that didn't seem right.
Or 330, it's 338.
All right, thank you.
338.
338. You can add or subtract, but you got to get a positive or negative. Do I got another positive one? Now,
Yeah.
Jonathan added 360 right away, and he got a what?
1,050.
1,000.
58.
So that's another one that would work. There's lots of answers. In fact, there's an infinite number of answers here. We could keep listing answers. Now, I wanted one positive, one negative. I've actually got two positive. I need to keep going until I get a negative one.
Negative 22.
Negative 22. Just subtract 360 from the 338, and you'll get to negative 22. Any questions there? What are you going to have to do with radians?
2 pi.
Add or subtract 2 pi until you get to a positive, negative coterminal angle. So let's do negative pi over 3. Negative pi over 3, if I add 2 pi to it, okay, what's the common denominator? 3. So I'm going to have negative pi over 3 plus 6 pi over 3. What would that give me?
5
5 pi over 3.
There's my positive one.
Negative 7 pi.
Now I need a negative one. If I go negative pi over 3 minus 2 pi, it's going to end up being negative pi over 3 minus 6 pi over 3. I don't have to find the common denominator again. I already have it. And if I go negative pi over 3 minus 6 pi over 3 instead of adding it, I'll get what you guys are saying, negative 7 pi over 3. So there's my positive and negative coterminal angle. Okay, real quick, arc length and area of the sector, and then I'm going to show you what to do for homework tonight. I'm done. Okay? How do you find arc length?
You take your
Please don't make this complicated. For crying out loud. This is probably the easiest thing I'll teach all year. It is as simple as knowing the formula. Now, if you don't know the formula, it's going to be pretty hard. If you do not know the formula, it will be pretty difficult. S equals R times theta. What does S stand for?
arc length.
What does R stand for? Radius. What does theta stand for? The central angle, but it has to be in what? Radians. So S is arc length, R is radius, theta is the central angle in radians. So if I look at number 49, do I know the radius?
Yeah.
What is the radius? 15 centimeters. Do I know the central angle of the arc that I want to find? Yeah, here's the arc that I'm looking for. Do I know that angle measure that matches up and intercepts that arc or subtends that arc? Do I know it?
Yes.
What is it? It's given. All right, it's right there on the paper. Theta is 7 pi over 6. Is it in radians? Awesome. Do we have everything we need? Okay? It's not super hard because all I got to do is the formula says to do what? Multiply the radius times the central angle if it's in radians. So S equals 15 centimeters. Now, since it's arc length, which units do I want? Do I want angle units, radians or degrees, or do I want length units? I want length. So the radians really is going to be irrelevant here now. The reason we have to use radians is because it's in terms of a radius length, where degrees isn't. It divides angles up in 360 parts, is one of the reasons we use radians. So, and then it's 7 pi over 6, but the radians really don't really help us here. So we drop the radians, and then I reduce this. The exact answer, let's see, a 3 goes into this, 5, so it'd be 35 pi over what?
2.
35 pi over 2 would be the exact answer now, and it's in centimeters. Now, I usually like students to give me the exact value and the approximated value, because if you're measuring out the arc length in the real world, and you're an engineer, and you go measure out an arc because you're wanting to do a circular arc because maybe you have a pivot, and you want to see how much arc length it's going to cover, and then eventually you want to figure out the area of the sector to figure out what your pivot is going to cover on your cornfield or whatever, because pivots go circular, right? So if I do that, I probably would want to know what this is as a decimal. Okay, or maybe this is a watch, and maybe this is a gear on a watch, and you want to see how much it travels, the distance that gear travels from one sprocket to the next. So 35 pi over 2, what would that be?
54.98.
54.98 centimeters, and that probably makes more sense to the everyday person. You know, if you walk up to somebody and say, hey, I measured the arc out there in that field, and it was 35 pi over 2, they're going to look at it like, what are you talking about? But if you tell them, oh, 54.98 centimeters, then they'll be like, okay, that makes sense. I can deal with that one a little bit better. 50, same thing. 51, though, what are you going to have to do in 51 and 52?
Convert them to.
You had to convert the 75 degrees into radians. How do you convert 75 degrees into radians?
75.
Multiply by pi over what?
Pi over
180 again. What happens to the degrees?
Cancel.
Cancels. Let's see, what does this reduce to? Give me some. Give me some. Work with me. Come on.
5 pi over 12.
5 pi over what?
12.
5 pi over 12 is the radian measure. Now do we have our central angle in radians?
Yes.
Now we can find our arc length. This will be 19 kilometers. This is big. This is more like a something probably the arc that you travel along a latitude line or something. I don't know. 5 pi over 12. Trying to think, or maybe it could be like an orbit. I imagine kilometers. We're talking something very huge here. Okay. Or airplanes, they travel arcs. Did you know that? They don't travel straight lines. Did you know that?
That's why if you look on like the maps in the airport.
It's crazy. It looks like this.
Yeah.
Because they travel a straight line, it's like twice the distance. They travel the arc as the shortest distance in spherical geometry. Spherical geometry, straight lines is not the shortest distance, an arc is. Okay, if you become a math major, you'll study a whole other geometry. There's about 20 different geometries you can study, and one of them is called spherical geometry, and all the rules are completely different than what they are in Euclidean geometry. And I had to learn them all, and they really suck because you don't have a clue what you got. I mean, I'm just like, whatever. What does this end up being? You're just like, okay, I'll go with it. Because the shortest distance between 2 points in Euclidean geometry is a straight line, but in spherical geometry is an arc.
So which
It
one
makes
in
sense
our
when you
world?
say
It does when you make sense when you look at there. It's a sphere. Yeah, what now?
Nothing.
Okay, good. 19 times 5, what's that? Does that sort of look like it's going to reduce?
95.
So it's 95 pi over 12 kilometers. And if you wanted the approximated values, and guys, I'm going to tell you on my test, I do count a whole point off for missing units. Because on the AP exam, they give 1 point for units. On every free response question, you get 1 point for units. So I'm going to train you now, never forget the units, okay? Learn to do the units. Yes?
Do we have to have it in the radian form, or does it not matter?
You mean the exact value?
Yeah.
I like the exact and the approximated.
So both of
Just
them?
train yourself to do both.
Okay.
All right, this right here, pretty straightforward. We'll just do one here. I'll just do this 270, number 56. This is area of a sector. Maybe a farmer wants to know how much this pivot's going to cover on this portion of the field. He wants to know how much area it's going to hit. Okay, can you see where this is actually practical?
Yeah.
Okay, you got a pivot and you want to say, okay, I want to know how much area it's going to sweep. I need to know how long my pivot needs to be. So maybe he knows the area. Maybe he knows that the 270, but he needs to figure out the radius of the pivot. He needs to know how long of a pivot to buy to cover that much area. So he'd actually be working backwards. He'd know the area, he'd know the angle, he'd be looking for the radius, and then he'd call up the company that builds pivots and say, hey, can I get a pivot this long? Okay? So area is 1/2. Now we know the length of the radius. It's 13 miles. What do we do with it though?
Square.
You square it, because it's 1/2 r squared times theta. And then we got theta, 270, but I got to convert it to what? Radians. What's 270 in radians without going anywhere?
Pi over 2.
Yeah, that one's good. 3 pi over 2. Now watch this. I'm going to do exact values here. You ready? 13 squared. Help me out here.
169.
169
4.5.
times 3 pi over 2. I want an exact value first.
Okay.
All right, 2 is not going to go into 169, and 2 is not going to go into 3, so it looks like it's going to be over 4, correct? So what's 169 times 3? Big. Help me. I'm standing here.
Is it
Helpless.
507?
Huh?
Is it 507?
Is it? I don't know.
I don't know. Is it?
507, good job. 507 pi, and it's, what's the units?
Miles.
No.
Mile squared.
Why is it miles squared? Because we squared that dimension. The dimension got squared as well. So the length got squared, so it's miles squared. It's square miles. That makes sense. Have you ever heard them talk about an area in square miles? Now, when you look at maps and geography, they say the square mileage of the states. You know, it says this state is so many square miles, this city is so many square miles. Did you know that you could fit all the population of the world in Texas, and New York City is still more crowded? Does that baffle you at all?
You can fit the whole.
You can fit the whole Earth's population, 7 million people, in the state of Texas. In New York City is still more crowded. And if you don't believe me, go to Wikipedia or go to Google, figure out the square miles of New York, figure out the square miles of Texas, take the population of New York, take the population of the world, divide it by the square miles, and you will see that there are more people per square mile in New York than there are with all the people in the world in Texas. I figured it out. I have to prove it every year to people.
New York or New York City, did you say?
What?
You know why New York City is so much more
You
crowded?
say New York or New York City?
New York City.
Because New
It's
York
not
City
that
is a
big and
city.
there's so many
Because
people.
it's so small and people
Stack.
live on top of each other there. Okay? Isn't that crazy you think about that? Because then we think, well, the world's really overpopulated. Not really. The world's kind of a big place. It's still pretty roomy here. We could all live in Texas and just be like we're all living in New York. It'd feel like New York. If everybody in the world lived in Texas, it'd feel like New York.
Let's say the whole U.S. could fit Rhode Island. And you have your own
And the whole
square.
state would be full of skyscrapers. It'd be crazy. All right, just be walking around all the time. Skyscrapers, skyscrapers.
That would
All right.
do that.
That would be cool.
That would be
Class
awesome.
It would suck though. All right, find the value of the indicated trig ratio. Here's going to be your homework for the rest of this. I'm not going to go over this, but write down SOHCAHTOA is all you need. So, a
Is
deer.
it
No,
more?
a needle pulling thread. I did it again. Third hour the other day I sing so. So this is a shout out to you, third hour. I started singing so, a deer, a female. They're like, Morris, you're singing it wrong. It's so, a needle pulling thread. Tea, a drink I pour myself. I drink with jam and bread or a lot of sugar Mr. Morse pours in it.
Let's just not.
Far, a great Star Wars movie.
Morris.
Anyways.
Is it Morris?
Was
Are
there what?
we assuming that it's a unit circle?
Nope, you're not assuming it's unit circle. This is just review of right triangle geometry.
59?
So like, for example, cosecant. I know cosecant is the reciprocal of what? Sine. So when you do 59 and you're like, okay, I know how to do sine. Sine of theta, SOHCAHTOA. So, a deer, a female deer. Ka, toa. Sine is opposite over what? Hypotenuse. Therefore, okay, therefore, because we want to see what it's there for, you go to cosecant and you flip it. Hypotenuse over opposite. So simple. So if this is theta right there, my people, there's theta. Which one's the opposite side? The 24. Which one's the hypotenuse? So it's going to be 25 over 24 for the cosecant of theta. Does that make sense?
You don't have to do anything other than
That's it. That's all I want you to do. That's all I want you to do for that part. Hold on, I've got a couple more minutes before I got to leave. Okay, I got to get this done. Solve the right triangle. Or no, in triangle ABC, C is a right angle, find the value of the indicated trig function. You're basically doing what I just did up there, but I'm only giving you two sides. How are you going to find the third side? Pythagorean theorem, a squared plus b squared equals c squared. Make sure you draw angle C as the what? The right angle, which means little c will be the hypotenuse, okay? Down here, the next part, find the measure of the indicated angle. Just to mention this real quick, and I think I'm going to almost be done. If I want to do this one, theta, see I got about 4 more minutes. Theta, I've got the what side right here? What's 6.4?
the opposite.
Opposite. What's the 5? The ADJ.
The tangent.
The adjacent, the adjective. Oh, wrong class. Okay, the adjacent. So if I've got the opposite and adjacent, and I don't have the hypotenuse, I'm not using so because that one wants hypotenuse. I'm not going to use sine because sine requires the hypotenuse. Cosine requires the hypotenuse. So which one do I use that I don't have to know the hypotenuse? Tangent. So I'm going to go tangent of theta is equal to what? 6.4 divided by 5. Now, you guys are not probably remember how to do this. If I want to do this in degrees, your calculators must be in degrees. You have to go to mode, M-O-D-E, and convert it to degrees. Make sure your calculator's in degrees. Say it with me. Make sure my calculator's in what?
Degrees.
All right. Then, what do you do to do this? You use, this is the first time we've talked about it. to undo tangent, logs undid exponentials, multiplication undid division. How do you drive backwards with tangent?
Inverse.
Inverse tangent. So you're going to hit second tangent. It looks like this. Tangent to the -1. That doesn't mean a -1 exponent. That means what? Inverse of 6.4 divided by 5, and you'll get a degree measure if your calculator's in degrees. Are you remembering this?
Yeah.
I'm trying to... Did you have geometry?
Yeah.
With G.
I got like half of you shaking your heads no. I got one person shaking their head yes. How many remember this? Just lie. Okay, good. If you don't remember, this is why we're reviewing it. I've only given you one day on this, because tomorrow, all new.
How would you want the answer? Just
In
say,
degrees.
just say tangent equals 52 degrees.
No. You say theta equals what? 52 point, round to the nearest 10.
0.00.
Okay? Let's see, is there anything else? That's the same thing.
What are we rounding it to?
I want you to go up to 76 tonight. Round to the nearest 0.1, nearest 10. Go up to problem 76 tonight. You may get started. That's all I wrote. Or all I have for you. No, cross-country kids, wait just a second.
Say something funny to end your video.
Morris, can I go to the bathroom?